This is Roshan here again. In this lecture, I am going to discuss about clear understanding of classical bit and qubit. Classical bit can be either 0 or 1, whereas qubit is superposition of 0 and 1 simultaneously. That means first we'll understand superposition. So, what is superposition? Superposition in quantum mechanics is a weighted sum or linear combination of two or more quantum states. That means we know that for one qubit we'll have two states. What are that? 0 state and 1 state. And also remember, 0 state is called as ground state. What it is called as? Ground state. And 1 is called as excited state. In other words, simply we can call it as down state and up state. Okay, remember these things. And now we'll see how a qubit is represented. Usually qubits enable quantum computing that can solve problems much faster than classical computers by leveraging superposition and entanglement. So to explain about superposition, let's take an example: flipping a coin once. So classical computer, in classical computer, what will be the probability of head? It is 1 by 2 straight away. And what is the probability of getting tails? It is also 1 by 2. But in quantum, remember, a person, just visualize the way I explain, then that will be very easy for you guys to understand it easily. What does the superposition means? Let's say a person is flipped a coin in air. Okay, so until it reaches the ground, once it reaches the ground, its probability will be 1 by 2 1 by 2 with respect to head, with respect to tail. But can you guys identify what will be the probability when it is in air? It's difficult, right? So here comes the quantum superposition. A qubit can be in a state that is a superposition of both 1 and 0 simultaneously. Okay, it can be represented as alpha 0 state plus beta excited state. Here, these are the two new terms. Okay, it is called as amplitude. What it is? Amplitude. And beta is called as amplitude of excited state. Alpha is called as amplitude of ground state. Okay, now how you will represent this quantum state using Bloch sphere. So the mathematical, first we look into the mathematical representation of Bloch sphere. It is phi e to the power of I gamma cos theta by 2 ground state plus e to the power of I psi theta by 2 excited state. Remember this formula, it's important. Okay, here theta, phi, gamma are real numbers. Each suppose let's say theta represents, it determines the balance between ground state and excited state. Be familiar with the terms when I say the ground state and excited state, don't get confused. Represents relative phase between ground state and excited state. Okay, now gamma, basically it is a global factor in this representation, and it doesn't affect our measurements. It doesn't affect measurement. So if the gamma is not affecting our measurement, we can rewrite the formula, right? Yes, now we'll write it. Equal to cos theta by 2 ground state plus e to the power I sin theta by 2 excited state. Okay, so what do you guys understood from this? Sorry. Superposition means a qubit can be present in both the state set simultaneously, whereas classical bit cannot do that. Classical bit can be either 0 or 1, but qubit can be of both the states simultaneously. Okay. Now we'll look into another property, entanglement. Okay. Entanglement in simple way, suppose uh, let's say the properties the properties of two particles, let's say the properties of two particles, any two particles are related even if they are separated. That means even even if you separate, even the particles are separated by distances, but they both have the same properties. Okay, I'll give an example. Consider you have two boxes. Okay, uh, let's say our state space of the boxes is one red color ball and one blue color ball. Okay, so we don't know in this is box A, this is box B. We don't know in which box we are having red ball and blue ball. Okay, suppose if a person had taken a ball from box A, the probability of box A will be he will be getting a red color ball. So since we are having only sorry since we are having only two possibilities, if one is red, what will be the another? Obviously it is blue color. Okay, this similarly it looks like your coin toss, similar to coin toss. But what if there are three possibilities? Take an example of rock paper scissor game. Rock paper scissors, everyone is familiar with this game. What happens here? Two persons will be there. It doesn't matter how far they are sitting. They might be sitting at 5 meters, 10 meters. It doesn't matter. They both have same properties. He need to show any symbol, and person A also need to show any symbol, and person B need to show any symbol. If rock appears here, then there is a chance that he may give a rock, because he doesn't know what he is going to do. Okay, he might give rock or paper or scissors. Even he might give rock, paper or scissors. So even these two people are separated, but they both are having the same properties. They both are going to play the same properties. Okay, then till now we understood superposition, entanglement. Now I'll show you the representation of qubit. Representation of qubit. It is your ground state and This is your excited state. Okay. Now we already discussed about the amplitudes. Alpha is the amplitude of the ground state and beta is the amplitude of the excited state. Suppose in a numerical example, if we want to find the probability of ground state, what is the formula? Probability of getting ground state is mod of alpha square. Similarly, probability of getting excited state is mod of beta square. Okay, these are the important formulas. Next, suppose you may be having doubt, sir, suppose let's say we have an error, so we are thinking that the values of the probability are wrong. How to verify? In such scenarios, you can verify your answer. The condition is mod alpha square plus mod beta square should be equal to 1. Why? In probability, we know that the probability will be in the range of 0 to 1. So, if the alpha square and beta square is equal to 1, then only the probability of getting state 0 and state 1 are correct. If the probability of ground state and excited state doesn't satisfy this condition, then then there is an error in your quantum state. Okay. We'll take a numerical example to understand it easily. Numerical example. Suppose we are having psi of 1 by 2 and root 3 by 2. Okay. We know what is the formula to represent quantum state psi alpha ground state plus beta excited state. Okay, so what is the alpha value? 2 0 plus beta value root 3 by 2. Now probability of getting is mod alpha square. So what is the alpha? 1 by 2. So 1 by 2 square, that will be 1 by 4. Okay, and probability of excited state mod beta square, that is root 3 by 2 whole square, that will be 3 by 4. So we got the probabilities for both the alpha state and both the alpha and beta. Now we'll verify. How will verify? We know that amplitude of ground state plus amplitude of excited state should be equal to 1. So 1 by 4 plus 3 by 4 equal to 4 by 4, that equal to 1. It matches. So this quantum state is existing correctly. Okay, that's it for the day. We'll see you in next lecture. If you find my content interesting, do subscribe, share, comment. See you in next video. Thank you.